Tell me to record. Remember me to record because I forgot my last class too. I have the old videos. I can just. That's what I did for my other one. I just threw up my old video.
Scroll back, sit there for a second, just scroll that next.
Yeah. Yeah. All right. So we've got y equals x to the third, but I need this in terms of x equals, not y equals. So I've got to solve this. How do I get rid of x to the third? Cubed root. So that's the same thing as saying the cube root of y equals x. Okay? Cube root of both sides. It's just like square root. You have to take care of the...
I think I remember what it is after, but
yeah. All right. So that's that piece right there. That's my r. So that equals r. So my ax, or actually ay, is pi r squared. So it's pi, the cube root of y squared. Or if we, so pi y to the 2 thirds. So that's the area of that disk at any point on the y-axis. Since we're looking in terms of y, we're looking at the y values for my integral. So we're looking going from 0 to 8. So my integral is from 0 to 8 of pi y to the 2 thirds dy. Okay. Flip to another screen to do that actually out. All right. So what's the integral?
3 pi to the 5 thirds.
So we're adding 1.
Yeah, you get 5 3.
Okay.
It's over 5 thirds.
So it's y to the 5 thirds over 5 thirds. Right. So we've got 3 pi over 5 y to the 5 thirds. And we're evaluating from 0 to 8. So y to the 5, or actually, we'll just, so 8 to the 5 thirds. For those of you who don't actually remember how to do this, you can pick either direction you want to go. In this case, doing the cube root of 8 is easier. So the cube root of 8 is 2. 2 to the 5th power is 32. So I have 32 times 3 pi over 5, which gives me 96 pi over 5. And that's my volume. So notice the method doesn't change when I'm doing it over x or over y. It's still just the area. The piece that's always going to be the annoyance is finding your r. That's the only part that you actually have to do with this. Once you find your r, it's an integration.
But this only works with circular.
Correct. These are only going to be the circular pieces. All right. Since he asked for it, I'm going to do it. Here's your washer. I was planning on it anyway. All right. So again, like I said, the hard part is your R. So when we're looking at the washer method, or it's still the disc method, it's just it has a hole in it now. We have multiple areas. You're always going to end up finding your area down to the x-axis. So what we want to do is we want to find the outer area, just like we did in the last class when we were looking at area. You find the biggest area, and then you subtract off the inner area. Same thing you're going to do here. You're finding the outside area, and then you're going to subtract off the inside area. So what you need to do is you need to know where the two equations are to figure out which one's on the bottom, which one's on the bottom, and which one's on the top. So in this case, we have the y equals x on top and the y equals x squared on the bottom. So my outside one is going to be pi x squared. My inside one is going to be pi x squared squared. Does that make sense? Yes.
You go over the difference between those two cases again.
So when you're looking at this, the disk, it has a hole because we're cutting it off. We're cutting off this bottom section. So the x rate or area, the x disk would go from there all the way down to that line. That's my outer one. My inner one is going to come from this line down. That's what I don't want. So that's why that's the inner one. That's the one I'm going to subtract off. No? Yes.
So, like, on picture A,
Yep.
rotated, and like picture B is like the 3D
Yep.
visualization.
Mhm. And then picture C is basically what the disk would look on head on. So this right there is your y equals x. That is your y equals x squared. That's the inner ring. I know. The hardest thing I ever had was literally trying to visualize 3 dimensions on a piece of paper. It's tough.
And picture C is just that one slice.
Yeah, it's looking at head on that one slice. So as we go, that area, the red part is going to get skinnier and skinnier because they're getting closer and closer together. That's like over here, the red part's a lot skinnier than down here. So that red part changes as we go through the shape. Yes.
Is this
Shouldn't y affect the
Why? No. Between 0 and 1, it's not. After that point, you're right. Between 0 and 1, it's not. So, yeah.
All right, so problem with me is how do you know if it's a disc or not? Because I remember we did the piece of paper, it would have, the questions, but it didn't specify use disc or use washer, right? So
Yep.
you have to figure it out yourself. I'm a little stupid, so how would you figure out if it's a disc or a washer?
If you give me about half the class, when I get to actually talk about the cylinder, the disc and washer is the exact same thing. Nothing changes. You're talking about disc and cylinder. How you know which one to use, which I'm going to get to. So, all right. So this is the area that I'm looking at. Okay. I'm looking at this space in here. And I don't think I'm going to be able to shade the correct thing. That's okay. So that right there. So I'm looking, so that red piece right there, okay, is the part that I want. The one that's double shaded down the bottom, I don't want. So when we're looking at the area, I'm going to cut the blue part out of the red, and that's going to give me that hole as it changes.
So if you wanted to get the region that is, if y equals x didn't exist, there wouldn't be there would be no hole.
Right, there'd be no hole. I would be just doing I would be doing just the blue part, and there'd be no hole.
And that would just be like the previous examples.
Exactly, no different than what I was just doing the last one. So, all right, so we've got our inner and our outer. You're just subtracting it. So when we do this one, my integral is going to be the same. We're doing it from 0 to 1. We have pi x squared minus pi x to the 4th. And if you don't remember that x squared and x squared squared is x to the 4th. So that's where those came from.
Do it all in the same integral?
Yep. Since there's pi in both of them, I can pull out the pi. And we're literally just going to do x squared minus x to the 4th. So x to the 3rd over 3 minus x to the 5th over 5. And we're doing it from 0 to 1. So I have pi 1/3 minus 1/5, which equals 2 pi over 15. I will do another one of those. Before I do the next thing, so it's going to confuse that part. Yes. Yeah. Oh, okay. Let me get another one of these. Let's do this one. All right. So this is about the y-axis. All right. So what's the first thing we have to do? Yeah. So, well, this is to y, so it's left and right. But yeah, we have to figure out where that's all happening. All right. So we graph it, and we get this.
Why does it like flat now?
Because y to the fourth it goes to zero. It doesn't, it gets to zero quicker than y squared. So it's not flat, it's just really small values.
Right minus left.
All right, so we're looking, which one's going to be my outer?
Y.
Remember, we're going to the y. So the outer one is my right one, which is actually the 2 minus y squared, the green one. The inner one, or the left,
Yeah, left.
is the y to the fourth. That's okay. The hardest part of this is not actually, I don't think it's the integration. Actually, in the vast majority of cases, the hardest part is not going to be the calculus. It's literally visualizing it to figure out what you have to put into the problem. All right, that's why I'm spending more time on that than doing the simple integration at the end. All right, so, okay, so we've got the outer and the inner. We also need to know where they intersect. Okay, you can solve this out algebraically. This one will work algebraically pretty easy. Since I already have the graph, I'm literally just going to click the points and find the numbers this way. Also, what do you notice about this graph while we're looking at it? Yeah, it's symmetric, right? So I could cut this in half and just look at the top half and just double my answer. Okay, does everybody understand how I can do that? That's going to save us. Whenever I can plug in a 0, it's going to make my life easier than having to plug in -1.
You're going to let us do use calculators to like see these things.
Yeah, you'll be able to graph it. Yeah, you'll be able to use Desmos on your thing to actually graph it and visually see it. Yes.
I'll ask after class. It doesn't like particularly pertain to calculus.
Okay. Then yeah, you can ask it. All right, so I've got this. So my area, the outer one, is my green one, which was that's the green. So I have got pi 2 minus y squared squared. My inner is pi y to the fourth squared. And my integral, I'm going to do 2 times 0 to 1. Because I'm just going to cut it in half right there. So we've got pi 2 minus y squared squared minus pi.
Are you left to distribute that?
Yeah, I'm going to do that in a second. I figured I'd write it all down and then I'll go through and distribute and clean it up a little bit. So that's my integral. So I guess the biggest question is, does it from the picture to the integral? Before we worry about the integral. Are we good to that point? Awesome. All right. Now let's manipulate and clean this up a little bit. So because I'm doubling it, because I'm cutting it right in the middle here. So that's where the 2 came from. Instead of having to do it twice or doing it from -1 to 1, I can do it from 0 to 1 and just double it. That 0 makes my life easier. Yeah. Huh? We found that with the intersection points. Desmos gave that to me. So you could have plugged them equal, set them equal to each other and solved it. And you would have gotten -1 and 1 when you did it out. But it's just easier to, since we already had it graphed, just clicking them and finding it. All right, so this one's easy. That one's just y to the 8th. This one's going to be 4 minus 4y squared plus y to the 4th. Yeah.
Not gonna lie.
Did you just distribute and get 2 minus y to the fourth?
I got 4 minus y to the fourth.
Oh yeah, sorry, 4 minus y to the fourth.
Squared.
See, what did I tell you? It's one of those things. One of those things people are gonna do. And before class, we went through like all the my little pet peeves. That's one of them. It's like people are gonna do this. There we go. All right, I'm gonna pull out the pi since that's just a constant, so I don't need to keep that in there. And then I can put all this down. So I have 4 minus 4y squared plus y to the fourth minus y to the eighth dy. 4 times 2 since
Okay,
it's
yeah, sorry.
that's okay. And nice thing is now it's a simple power rule integration. Pi 4y minus 4/3 y to the third plus 1/5 y to the fifth minus 1/9 y to the ninth. 0 to 1. Yeah, I did all this right. So now we're plugging in the 0, everything cancels out, so I don't have to worry about that one. So I have 4 minus 4/3 plus 1/5 minus 1/9.
Which is
248 over 45.
I did not do that one.
And then times 2 pi.
I already did this. I already did this too. Yeah. Yep. See, I literally just put it. That's what I could do. And then just click the little button right there, and it changes from a decimal to a mixed number or a proper fraction. This is how I get around all those wonderful significant digits and figures and things like that from chemistry and science class. Just leave it as a fraction. You don't have to worry about it.
That's the edge of why you use them when you can just use a fraction.
Exactly. All right, let's be exact. All right. Questions with that? Okay. So we're going to take the exact same 2 equations that we just did. Except this time, I'm not going to rotate it around. Actually, let's delete that. I'm not going to rotate it around the x-axis. So we're going to look at the same, this is the same one we did here. This one was rotated around the x-axis. And we got a shape that looked like that. We're going to do the exact same thing, except we're not going to rotate it around the x-axis. We're going to rotate it around y equals 2.
So it's still y equals x.
Yes, it's still y equals x and y equals x squared. And we're still doing it between 0 and 1. Okay, but this time, we're doing it no, I was graphing it. So we're taking this little chunk and we're rotating around that line. Okay. So again, we're looking at radiuses. That's the key piece. So actually, first thing before we do that, which one's my outer and which one's my inner?
So once,
X squared is my outer or inner? Right. My x squared is now my outer one. My x is my inner one. Because we're looking at it in relation to the y equals 2, not the x-axis. Okay. So that does change things a little. All right. So when we're looking at the radius of the outer, it ends up being 2 minus the x squared. Because remember, we're still going down to the x-axis. Okay? Because whenever I'm looking at the calculations, it's going from whatever I am down to the x-axis. So this down to that axis is the 2. I'm subtracting off that little piece, that x squared. So 2 minus x squared is going to be that to there. Yes. Yeah. Okay. Well, because these are the visualization things that are actually very difficult to actually get. So I want to make sure we understand where those things are coming from. So that's 2 minus x squared squared. The inner works the exact same way. We're looking at it, again, from the 2 all the way down, that's the 2, and we're subtracting off that x. So pi 2 minus x. All right, take a minute or two and set up my integral. And we're still doing it from 0 to 1.
We still need R.
Have fun, R. That's R the outer, that's R the inner. That's what you should have gotten for your integral. Huh? Well, you did. You have to FOIL that out, and you have to FOIL that out. It just simplifies down to that at the end. I know. Unfortunately, if you don't FOIL, then you have to do other things, which makes your life a little more complicated in integration. In like derivatives, all it would do is basically make you have to do the chain rule. In integration, you'd have to do your substitution, and sometimes you can't, like in this situation. So then we do the integral of that, and you get 8 pi over 15. End up getting 8 pi over 15.
Finish it.
I know. I literally copied and pasted it. I didn't write it out. Yeah, I think that's what I'm going to do.
So in Calc 2, we're just visualizing everything.
A lot of it is. A lot of, so chapter 6 is, chapter 8 is, chapter 7 is all the other methods on how you can do integration. Like right now, you don't have a rule that undoes the product rule, for example, for differentiation. You don't have a rule that undoes the quotient rule. We have integration rules that do those. That's the integration by parts and partial fractions and stuff. So we have to go through that. That's actually where most people consider that the hard part of Calc 2. That's the chapter they think is the hard part of chapter 7.
I like partial.
You might be the only one in the world. I hate
I hated you said, because I missed the first week last semester, so I didn't really know you stuff at all.
Yeah, that's so. All right. I'm gonna change things up a little bit, but that's okay. All right. So I'm going to I was going to do the cylinder method today as well, but I think I'm going to do that next time. I want,
Sorry, should we move on?
no, I haven't moved on yet. I'm literally going to, I was letting you guys do that, but I was debating on what I was going to do. But it's like, I'm not overly confident that you guys could do this well on your own right now. So I'm instead of moving on.
Sorry, I thought you meant moving through the slides. I thought you
Oh no, I literally was deleting the slides. So instead of me going on to the cylinder method, which is going to flip things around on you, I'm going to do some more problems with this, and we'll do the cylinder method on Tuesday. So I want to do a couple of problems with these first. Let's.
negative number.
Oh, I can look at that. Hold on.
Close it out, right?
Did you get?
I have negative 5/3 plus 1/5 plus 1/2.
1/2.
Oh well, yeah.
Yeah, it should be. That shouldn't be 1/2. That should be 2. That was probably the mistake. Yeah. Normally,
I
if
can't do 4 divided by 2.
You know,
That is my problem.
it's okay. I mean, normally, if you get the right answer but it's the wrong sign, you did things backwards. Like you did your inner and outer backwards. That will actually give you the negative value instead of the positive value, which can happen. That absolutely can happen.
then you just go, oh, yeah.
Yeah, and then you just flip. You realize that wait, area can't be negative, neither can volume. So something's wrong.
Then you flip the side column again.
All right. let's do this one. So take a few minutes. I'm gonna walk around. Well, that was fast. Her lab started at 5:30. She's already over. All right.
We usually do like safety for the first lab.
I told her, I was like, you're gonna have a test your first class. And she's like, they're already giving me a test. Yes, you'll be fine. I'm like, they're basically just telling you what not to do to kill you. Don't kill yourself. Use your phone. Graphic.
Oh, good question. I used SolidWorks and Unity.
Yeah.
Which.
Oh yeah, you can just graph it around. Yeah, I use Fusion 360 to do all my modeling. So, just because, no, sorry. All right. I got to look at which piece you're looking for and find me the two radiuses. So what you guys need to find basically is this. The outer. Come on. And the inner. Yep. Use the graphing calculator. The graphing, not the scientific. Otherwise, it won't give it to you. It won't show you. Yep. So we're rotating.
I'm supposed to care about, but
No, so we're rotating that little space. So we're rotating that little space
the one up here.
in between. Yeah, that's the space. Right.
Because are we essentially subtracting? this?
Yeah. So now the question is now you need to find because we're rotating it around y equals -1. You're rotating it around down here. So you need to find your radius for each of those.
Okay. So should I, instead of typing this, should I have typed?
No, that's fine.
Y?
Well, I did.
That just makes it
That's what I did.
one.
But no, that's fine. What you did was,
It just makes a frickin' line.
yeah, you visualized like the actual like range of where you're looking at. So that's fine.
How did you get rid of?
I put it here. And that restricts the thing. So I'm just looking at that one piece. Huh? I don't know. I haven't done this one out yet. I haven't gotten that far yet. You think I planned these things? I planned like 7 other slides that I didn't do. So this is all me like making crap up as I go. Oh, on the keyboard, it is.
It's better to do it like this. So we used to having like 3 computer screens.
Oh, hit the ABC button.
If you were to be adding that plus one, you'd only have
Hit the ABC button on the calculator. It's down the bottom.
Yes.
How come yes? No.
This is why I like a keyboard. All right, so if we're looking at this, pretty much everybody got to this point where they had it graphed. It's we're good to there. What's going to be my outer? What's going to be my inner? Right. So cosine's my outer, sine's my inner. So we got that. So if we're looking at this, bring this over here, so I can draw on it. Okay. So my inner is going to be from here to there. That's my radius. My outer is from here to here. That's my outer. So what's the equation for my outer? Yes. Why is it plus one and not minus one?
Because when it goes to the x-axis and negative one is below the x-axis, so you have to add.
Correct. So this is cosine of x. And that part is the plus one.
Right, you're set for the right thing,
Yes.
for the power 4 and 0.
Yes. So I'm just looking at the piece I'm rotating. All right. Everybody understand where that came from? Okay. So you understand how from here, that's fine. Do you understand how I got from here to here as cosine? Okay. And then since we're looking at it to the x-axis, I then have to add the one below the x-axis to get the full radius. So from there to there is cosine, but I'm really coming down to here. So I just need to go another one down. That's where the plus one came from. So my outer is cosine of x plus 1. Because I have to add that extra piece down the bottom. In the last problem, remember we did the 2 minus because we were above the x-axis.
Oh, and it's plus one, so it's plus
It's
one
below-
for
right,
whatever
it's-
cosine x is.
Yeah, because I have that piece, then I have the whole part down the bottom that I still have to keep going. All right, now my inner is going to be what? Yeah, because that's my sine of x, and that's my plus 1. You got to remember when you're looking at the integral, it's always going to be rotating it around the axis that it's looking at. So either x or y. So in essence, what we're doing by adding the 1 is we're taking this whole graph and we're shifting it up by 1 so that my rotation is around that x-axis. Okay. So if I looked at Desmos, thank you. If I did sine of x plus 1 and cosine plus 1, I know. Share. All I did is I shifted it up 1. And that would also shift up 1. So I've shifted everything up 1. That's the exact same picture I had before.
Why do you care that it's rotated about the x-axis? That situation.
Because that's what the integral is going to do. The integral is always looking at it going down to
Yeah.
the x-axis or down over to the y-axis, depending on if you're looking at the y-axis. So when you're looking at something that's not on that axis, you're looking at how you're going to shift it for that to happen. Okay, and that's why we're adding 1 to this one. Yeah, I don't know if the graphic.
My auto rotates on. but it's-
Yeah, I don't know if the app. It does rotate.
Yeah, you have an Android?
Uh,
No, I know the Android does.
I just looked, like my auto rotate is on.
if you scroll down like this, on top.
Oh, yeah, no, I looked.
Yeah, it's on.
Oh, it's off.
Yeah, no, it's on.
Weird. All right, let's go do some algebra. So we have to find out the cosine x plus 1 squared and the sine x plus 1 squared. The pi is just going to come out, so I don't have to worry about that part. So cosine x plus 1 is going to be cosine squared x plus 2 cosine x plus 1. And then I have sine squared x plus 2 sine x plus 1. Yeah. That's not what I wanted to do. All right. So make up my integral. It does. You need to remember a trig identity. Huh?
Oh, yeah.
No. That's cosine x or cosine squared x plus sine squared x. You should have minus. Remember, you're subtracting the inner and the outer.
And cosine squared minus sine x squared.
Yeah. So the sign's going to be negative. This is what happens when I just randomly pick a problem off the answer, the thing, and go, oh, this one looks good. I have to show you a trig identity.
There's cosine squared x minus 1 is sine x squared, right?
No, cosine squared x plus sine squared x is 1. There is an identity for cosine squared x minus sine squared x
Cosine squared x plus
equals 1, but we have minus, not plus. So that's not going to help me.
can't we
Isn't
make
it
our
like
1?
2 sines, cosine?
It's cosine 2x. All right. So let's write my integral. So we have pi out in front. We're doing from 0 to 1 still, right? We're still doing 0 to pi over 4, sorry. After I turn on its holder, we're not doing trig identities today. All right, so we've got cosine squared x plus 2 cosine x. The 1, so actually just do plus 1. Yeah, I'll do it out and then I'll. So when we put it all together, so I have cosine squared x minus sine squared x plus 2 cosine x minus 2 sine x, and that's it.
And there's identities, right?
Yes. So this one right here equals cosine 2x. So one of the double angle identities.
Well. Should have known that.
That's okay.
For the, is there an identity for the second one?
No. This part?
So we
No.
get
But that part I can easily do my integration for. The problem with this one is because it's cosine squared x, I don't have an integral for it to do. So you will when I start covering chapter 7. But right now we don't. So we now can do the integral of each of these pieces. So the integral of cosine 2x actually, we're going to skip that one for a second because I have to do some. We can do these really easy though. So 2 sine x. And then plus 2 cosine x. All right, so cosine 2x, we have to do u substitution for it because I have a function inside of a function. So my u is going to be 2x. My du would be just 2 dx. So I've got 1/2 du plus dx. So I end up getting 1/2 sine 2x.
Wait, so we got the 1/2 from the derivative
Mm-hmm.
out there, and then you just took the derivative of cosine.
Yep, which is sine. And then the u gets plugged back in. So one of the things that, so u sub can be used for a ton of different things. However, a lot of times you're going to see problems that look like this. Okay? Or even if it's like, believe it or not, even if it's like 3x squared, like we can do things like that. But for ln of, or not ln, or 1 over 2x, which is going to become the ln's, things like that. These problems we use what's almost known as implicit u substitution. So that number that's right in front of that will always become a fraction in front of whatever you have. So that becomes 1/2. And then you just do the integral of this as if it was just an x, which is the sine 2x. So if I had 1 over 2x, the same thing happens. I have the 1/2 because that becomes the 1/2. Actually, you know what? I'm not going to do 1/2. I'm going to do 5x. So that becomes 1/5. And then the integral of 1 over x is the natural log of 5x.
Even though the fifth is in the denominator, the 5's in the denominator.
Doesn't matter because my u
would
in
still
that
be-
case is 5x, not 1 over 5. Okay. So it doesn't make any difference in that regard. Okay. So anytime you have just a simple thing inside, it just becomes a fraction up front. I'll make your life a little bit easier to remember that, because that's basically what we just did here. That 2x comes to 1/2, and it just goes down. So you don't really have to go through all the steps to write out the whole thing for the U substitution for those type of problems, because that's going to happen a lot. Yeah, you won't have to do multiple U substitutions by just knowing that one little thing. All right, so we've got that, but we're not done because we still have to evaluate it. I have to plug in 0 and pi over 4. And in this case, 0 does not disappear everything. Nope, because cosine of 0 is not 0. All right, so we've got, we'll do pi over 4 first. So sine of, well, 2 times that, so pi over 2. What's sine of pi over 2? Is 1. So it's 90 degrees, sine of 90 degrees is 1. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2. And now we can do the 0. Sine of 0 is? Sine of 0 is 0. Cosine of 0 is 1, so that's 2.
So we get 1/2 plus 2.
So I have 1/2 plus square root of 2 plus square root of 2 plus 2.
Not minus.
Nope. Oh, yeah, it is minus 2. You're right. You're right. So I get negative 3 over 2 plus 2 square root of 2.
With positive attached to it, right?
What? Pi's been there the whole time. All right. Want another one?
Without trig identities.
Without trig identities? Okay, I give you one without trig identities.
We're gonna use this a lot, aren't we?
What?
This,
Finding value?
the washer thing.
Yeah. It is useful. We're not using it a ton. It is useful.
I have mine set.
All right, try this one. I made this one. This one's going to the y-axis, so you're not going to have to do plus or minus numbers to make your life a little bit easier.
Yeah, we already did this one.
Oh, we did. You're right. This was the extra one we did. That's why. I'm like, I thought that one looked familiar.
I know what I'm looking at.
You're fine.
I got it right here.
You said our test questions are taken basically straight from WebAssign.
Yeah.
Just different numbers of this.
Oh, actually, that reminds me. Something my other class has. Do this one. So right now I have just the homework assignment basically for the whole chapter, and I picked and choose problems. I can make assignments in WebAssign that are just practice assignments that have like all the questions from 6-1, all the questions from 6-2, all the questions from
Not
6-3.
graded, but just-
Non-graded that's just there. You don't have to do it, but it'll give you the ability to practice a bunch more problems
Yes, please.
if you want me to do that.
Yes, please.
Okay.
That way I don't
It
have
probably
to-
won't happen tonight. I'll do it tomorrow morning, but I will put, so don't freak out. I'm going to add a bunch of practice assignments for chapter 6 in there. So you can just do a bunch of those problems if you want. It's not graded. I don't care if you do it or not. It's literally just there for extra practice. Okay. The one that says chapter 6 homework, that's the one that's graded. The other ones will say practice 6-1, practice 6-2, practice 6-3. Okay. Yeah, I can do that. That's easy enough. It won't be curated. I'm literally just going to select all the questions they have. So skip through, do the ones, and I'll have it set that you can do it like 100 times and pick as many problems times as you want. So it's literally just for you to practice problems. All right, you got to find me my outer and my inner.
Say that you housing.
Six.
But that y equals 2, just like a constant.
Nope, it's a function. So, but it is a constant, but it's a function.
So I don't need to subtract or add anything.
Apply on the other.
No, not in that respect.
So just two,
It's just two.
like our second half.
It's just two.
Okay. Just wanted to make sure I wasn't.
No, I picked this one on purpose because I was trying to make sure that you like didn't think like, wait, why is there nothing, no X's there? You can't. It's just a two.
Is in between just 0 and 1.
No, you have to find out where they intersect. You can graph it for it. If you just graph them, it's going to tell you where they cross. You can plug it in and solve it. It's 6 minus x squared equals 2. And solve.
If x is 2, 6 minus 4.
Yeah. You're missing an answer.
What the other one? Negative 2.
Right. Now you have your 2 endpoints.
I just grabbed it.
Yeah. That's what your graph looks like.
So you would technically call it the outer one, the one on the top.
Yeah.
It's 6.
Hold on. What's 2 to the fifth?
32.
Yeah, I should have started.
That's what you should have had. That should be your,
Maybe.
Yes. Okay. So I could do-
Just do it.
yeah, you can, since it's symmetric, you don't have to necessarily do both.
And if you do it from negative, you get 0. So you don't have to change your.
I'm finishing writing because I already got.
All right, I just added, while you guys were stressing out about that one, the practice for 6-1 and 6-2. So they're there. So your integral should look like this. Oh, the other thing that I can give you, I can't post it anywhere. If you have the textbook and you want the answers to the questions in the textbook, you have the odd answers in the back of the book, but they're also not worked out. It's just the answers. If you email me, I'll send you the solution guide for the chapters.
You did zero.
Yeah, because it's symmetric.
Wait, I could make the two to two.
Okay.
That's the concept.
Yep, you should come out to be the exact same answer at the end.
It's exhausting.
What's wrong?
I'm just exhausted after today.
That one I can't help.
I gotta fix my sleep schedule. So I'm waking up at 8. And
Yes.
going to Philly.
Yeah, I'm kind of fixed myself.
I got up to integration.
Yep.
Doing my college applications right now, so it's like waking up early to get those done.
No, I didn't.
Did you get to the x to the fourth minus 12x squared plus 32?
I got x to the fourth minus 2x squared plus 32.
You forgot it's okay. So if it was 1 minus x squared, you'd have been right. It's a 6. So you have 6x squared and 6x squared, which comes up to the negative 12x squared when you FOIL it. So when you FOIL out 6 minus x squared,
Yeah, I got 36 minus x squared plus x squared.
that's what you should have got. The inner and the outer is 6 times x squared. It's okay. Every other one we've done has just been 2x squared in there because it's been a 1 you've been multiplying it by basically. So, and then you're minusing 4 from that because that's the 2 squared. That's where the 32 comes from. So you have x to the
I
fourth
know where the 32 is. I just
minus
didn't-
12x plus 32. It's okay. It's getting late. Those are the little things that happen, unfortunately, at this time. All right.
Will you be? I know you said for certain, I know you can be like 4:30.
I can be if somebody wants me to be here.
Does that apply for normal tests as well?
Oh, actually, so there's nobody in this room beforehand. So I'll be here by 4:30 for the test days. So you have an hour before
More or less.
class to start your test if you want. If you can get here early, great. If you can't, you can't. There's nobody here before you this class, and there's nobody here after this class. So if you need to go a little longer, that's fine. I'll give you the 8 instead of 7:15 on the test days. So, all right. All right. I think everybody's fried. And if I try to shove anything else into your head, it's just not going to work. So we're going to stop there.
You know, I feel pretty
Stop
good
my
about that
recording.
now that we did some more.
Yeah, no,